Hey everyone, welcome back. Do you know navigating by air or boat is generally done using vectors? You will use vectors to study electromagnetic fields, fluid flows, and other topics in engineering and physics. Okay, now coming back to today's topic, which is product of two vectors. So what is a product of two numbers? If I give you a two number, what will be the product? It will be a number. Similarly, if I give you a matrices, product will be a matrix. But multiplication of two vectors is defined in two ways: scalar dot product and vector cross product. Let's begin with scalar or dot product of two vectors. If A and B are two non-zero vectors, A dot B is equal to magnitude of A into magnitude of B into cos theta, where theta is the angle made between the two vectors A and B. If A and B is a null vector, then the dot product will be 0 because the magnitude will be 0. The dot product result will be a real number. Why? Because the magnitude will be a number and cos theta will also have a numeric value. If the vector makes an angle 90 degrees with each other, then the dot product will be 0 because cos 90 is 0, as you can see from the graph. If theta is 0 degree, then cos 0 degree is 1. So A dot B is equal to magnitude of A multiplied by magnitude of B. If theta is equal to pi, which is 180 degree, cos 180 degree is minus 1. So dot product will be minus of product of the magnitude of A and B. So we can conclude that I dot I and J dot J and K dot K will be equal to 1 because the angle that I makes with I will be 0 and cos 0 is 1. Similarly, the angle that I makes with J is 90 degree. So I dot J is equal to J dot K is equal to K dot I will be 0 because cos 90 is 0. Now A dot B is equal to magnitude of A into magnitude of B cos theta. So cos theta will be A dot B divided by magnitude of A into magnitude of B. So theta will be cos inverse A dot B by AB. So what are the properties of dot product? Dot product is commutative, which means A dot B is equal to B dot A. Dot product also follows distributive property, which means A dot B plus C will be equal to A dot B plus A dot C. Now, projection of a vector on a line. Suppose AB is a vector that makes an angle theta with the line L. So P is a vector where cos theta is equal to vector P by vector A. So P will be A cos theta. So the value of P will be what? A cos theta. So that's how P magnitude is calculated. This vector P is called projection vector and its magnitude is projection of vector AB along the line L. To keep it simple, the angle is always plotted in the anti-clockwise direction. For example, if P cap is unit vector along line L, then projection of vector on line L is vector A dot unit vector of P. Projection of A on another vector B will be vector A dot unit vector B, which can further be expanded as A dot B divided by magnitude of B. If theta is equal to 0 degree, then the projection of AB will be AB itself, which means it will lie on the same line. If theta is equal to pi, which means 180 degree, then the projection of AB will be minus AB, which can also be written as BA. Now, let's solve a few questions to make the concept more clear. So find the angle between two vectors where magnitude of A is 1 and B is given 2 and a dot b value is 1. So simply put it in the formula, a dot b is equal to ab cos theta. So from here we can get cos theta is equal to half. Now we know cos 60 degree is half. So we have theta as 60 degree. Now next question, find the angle between vectors a and b. So take the dot product, and we already know that I dot I, if we do, it will give us a value 1. But if we do I dot j cap, here I dot minus j cap, then it will give 0. So multiply I with I, j with minus j, and minus k with k. So that gives us theta is equal to cos inverse minus 1 by 3. Next question, show that the vectors a plus b and a minus b are perpendicular. So the first step is calculate a plus b and a minus b. For a plus b, let's say c, and a minus b we keep the value as d. So c dot d, if it is perpendicular, then the dot product will have 0. So let's calculate. Next question, find the projection of A on B. So we will do A dot B unit vector. Next, find A minus B if A is 2, B is 3 and A dot B is 4. So let's take out A minus B square, which will be A minus B dot A minus B. So multiply this and put the values of A square, B square and A dot B. So we have A minus B as root under 5 and magnitude cannot be negative. Next question, if A is a unit vector and x minus A dot x plus A is equal to 8, then find the magnitude of x. Since A is a unit vector, its magnitude will be 1. So x minus A dot x plus A gives us the value of x as 3. Now you have to show that A dot B magnitude will be less than equal to magnitude of A into magnitude of B. So A dot B is AB cos theta, and cos theta's value is always less than equal to 1, as we can see from the graph. Now multiply both sides with magnitude of A into magnitude of B. This gives us, and hence we can prove this. Next question, you have to show that A plus B is less than equal to magnitude of A plus magnitude of B. So let's do A plus B square. That gives us A plus B dot A plus B. Expand it, and from the last question we already know that A dot B is less than equal to magnitude of A into magnitude of B. So that gives us, and now we'll remove the square by either taking root on both sides, and here we can prove the equation. Now next question, show that A, B and C are collinear. So first calculate AB, which is B minus A, then BC. Similarly calculate CA. Now take out the magnitude of AB, BC and CA. So as we can see, if suppose we name AB as vector A, so we can see BC is equal to 2 times of vector A. Similarly CA will be 3 times of vector A. So this is collinear property, because as we can see A is equal to lambda B. This was one property of collinear vectors. Hence A, B and C are collinear. Let's begin with exercise 10.3. The first question is, find the angle between two vectors where magnitude of A is root under 3 and magnitude of B is 2 and A dot B is given root under 6. So simply put the values in the formula of A dot B and you will get the answer. Next question, find the angle between vectors A and B. Take the dot product. And the solution is cos inverse 5 by 7. Next question, find the projection of vector A on B. So we need to calculate the projection of A on B. So it will be vector A dot B cap, which can be further expanded to A dot B divided by magnitude of B. Put the values and the projection will be 0. Next question, find the projection of A on B. Take A dot B divided by magnitude of B. Same as the previous one. Now show that A, B, C is a unit vector and they are perpendicular to each other. Calculate the magnitude of A, B and C. As we can see, it's 1. So all the three are unit vector. Now calculate A dot B, B dot C and C dot A. So they are mutually perpendicular to each other because the dot product comes as 0. Next question, find the magnitude of A and B if A plus B dot A minus B is 8 and A is 8 times of B. So let's expand A plus B dot A minus B. So it comes as, now put the value of A in A square and then we have both A and B. Next question, evaluate 3A minus 5B dot 2A plus 7B. We know that A dot A will be magnitude of A multiplied by magnitude of A into cos 0 degree because A and A makes 0 degree with each other. So we can simply write it as A square. Similarly for B. Next question, the angle is given as 60 degree. A dot B is half and it is given that magnitude of A and B are equal. So let's put the values in the equation A dot B and we get A and B as 1. Next question, find the magnitude of X if the magnitude of A is given 1 and you have one equation X minus A dot X plus A is equal to 12. Expand the equation and put the values of A. So you get the magnitude of X as root under 13. Next question, if A, B, C are given and A plus lambda B is perpendicular to C vector, so you have to calculate the value of lambda. So this can be written as A plus lambda B dot C is equal to 0 since it's already given that they are perpendicular to each other. Now expand the equation, it will be A dot C plus lambda B dot C. Put the values and lambda is 8. Show that magnitude of A dot B vector plus magnitude of B dot A vector is perpendicular to magnitude of A dot B vector minus magnitude of B dot A vector, and A and B are not a null vector. So take the dot product. Theta will be same for both. So we conclude that they are perpendicular to each other. Now you are given A dot A is 0, A dot B is 0, then you have to say something about B, the nature of B. So expand the first equation, which is A dot A equals 0. It will be magnitude of A into magnitude of A cos theta will be 0. So here the theta will be 0 because A and A makes the angle 0 degree with each other. So since theta is 0, cos theta will be 1. So only reason for the equation to be 0 is if A is a null vector. So if A is a null vector, then in the next equation A dot B equal to 0, B can be anything, any vector. Next question, if A, B and C are unit vectors, A plus B plus C equals 0, then you have to find A dot B plus B dot C plus C dot A. Can you see a pattern here? Yes. This is similar to A plus B plus C whole square. So write it and expand it, which gives you A square plus B square plus C square plus 2 AB plus BC plus CA. Put the values and you get AB plus BC plus CA as minus 3 by 2. Next question, if A is 0, B is 0 and A dot B is 0, then can you say that if A dot B is 0, that necessarily will mean that A is also 0 and B is also 0? Let's see. If A dot B is 0, then we can have an equation where the value of magnitude of A will be 5 and B will be 4. And maybe the theta is 90 degrees, so A dot B is 0. So that does not mean that if A dot B is 0, it will mean that A is also 0 and B is also 0. We just saw, right? It also depends on other factor like theta, the angle between A and B. Next question, A, B and C are given. You have to find the angle between angle ABC. So first calculate BA and BC. Then take the dot product of BA and BC. So that gives you theta as cos inverse 10 by root under 102. Next question, you have to show that AB and C are collinear. So calculate AB, BC and AC, and now take out the magnitude of AB, BC and AC, and as we can see, AB plus BC will give you AC. Next question, show that A, B and C forms the vertices of a right angled triangle. So first calculate AB, which will also be equal to B minus A. Similarly calculate BC and CA. Now take out the magnitude of AB, BC and CA, and we can see by Pythagoras theorem that yes, this forms a right angle triangle. Next question, if lambda A is a unit vector, then what can you conclude? So for lambda A to be a unit vector, it should have the magnitude as 1. So it can only be possible if lambda is equal to 1 by magnitude of A, or A is equal to 1 by lambda. Thank you for watching. If you like the video, please like, share and subscribe.